Hi everyone. So we haven't really started yet, but I'll be just I think it's easier for me to answer your questions in this way, right? So keep posting your questions. I'll keep answering them, and we will start exactly at 7 o'clock, right? Okay. So let's see. No, I cannot take electrostatics. This webinar is on projectile motion. We will talk about that. Uh, let's see. So let me start from the beginning. What is motion? We'll talk about that in this webinar. Same. What is projectile motion? We'll talk about that too. This is my first class. Fantastic. Welcome to the class. Right. If this is your first class, hopefully you'll enjoy it. Every component of this topic, because over here, this is what in this 1 hour, the focus of this webinar would be to give you that one trick which is required to solve every question of kinematics. Right. That is what I'll talk about. Obviously, you cannot cover the entire kinematics or the entire projectile motion in 1 hour, but I'll give you that one trick using which you can solve all questions, any dimension, right? Be it one dimension or two dimension, be it three dimension also, you will be able to solve it if you follow that one trick. So that is what we'll spend our time on, right? Yes, we will include projectile motion on an inclined plane as well. Don't worry about that, Aditya. That is in fact very, very integral part of how how I prove that that one trick works everywhere. Yeah, so using that trick, you will be able to, there will be no errors in kinematics. Also, errors are a part of learning. So don't be discouraged if you have a lot of errors. That is not a problem. If you are able to fix your errors, right? Even if you take, let's say, 2 hours in solving a question and then you have an error and then you are able to fix it in the next 2 hours, then those 4 hours are not a waste. You have learned something. So don't be discouraged by that. All right, Ashish? Do we need to learn? No, you don't need to learn calculus to start projectile motion at all. Okay. Yes, you can be an expert in this topic after a lot of practice. So the idea over here is to give you enough material to start practicing. And once you start practicing, after sufficient practice, you will be an expert for the next, like forever, right? It's not that you'll be an expert for 2 months and you need to revise again. No, if you use this trick and if you practice efficiently, you'll be an expert forever. Even revision is not required. Revision will only be required to improve the speed. How many questions will be solved? We'll see. The time, according to the time, we'll see how many questions we can solve. Three dimension is not really in the syllabus, Alankar. I'm just saying that you can apply the same concept anywhere. Okay. No, inclined plane is not hard at all if you know that trick. So, we'll see. Aman, so in this, in this webinar, we are focusing only on projectile motion. So if I start discussing multi-concept problems, let's say, you instead of one projectile, you shoot two projectiles, or let's say one projectile which, splits into multiple components in the middle of the air. So that requires multiple concepts, and I'm not exactly sure as to how many of you are aware of those, right? So this webinar will not focus on conceptual questions as you're saying, but it will give you enough material to start practicing. And once those concepts are covered, it will be easy for you. Okay. When to prepare for JIPMER? Well, start right now if you haven't already. Yeah. See that worked for me when I started preparing way back in 2006, and that has worked for every student of mine. Right? Instead of learning too many different formulas and too many different tricks for special situations, that one process. Remember, that process is not something that you will apply in the examination. That process is what you will apply while understanding and practicing questions, right? And then when you practice enough questions, you will have already learned the formula. You will have understood the concept. Any special situation that arises, any one of those special conditions where the projectile is fired straight up or straight horizontally, or whatever is the special situation, you will be able to take care of that. That is the idea. Okay. There is no substitute to practicing, by the way, right? Attending a 1 hour or maybe 2 hours of webinar will not substitute the practice part. No, we are not covering relative motion, others, right? We might have a different webinar on that later, right? But right now we are not covering relative motion at all. Yes, H.C. Verma is a very, very important book. So I will also talk about in this webinar, I will also talk about 4 most important questions, and they will be at the end of the webinar. How to start preparing for JEE in general, right? And then what books to cover, how many hours to study, and what is the general process of covering a particular topic. So these are 4 basic questions that I will answer at the end of this webinar, right? Other than that, any question that I miss during the webinar, I will take up after the webinar, right? So the webinar is from 7 o'clock to 8 o'clock. After 8 o'clock, I'll stay back for half an hour, and I will answer any of the pending questions that you would have, right? And I'll answer these 4 basic questions that I'm sure all of you will have, right? What books to cover, how many hours to study, how to start, and how to cover various topics, right? So these 4 basic questions will be answered there. Okay, we'll try to cover the entire projectile motion in 1 hour. We have about 30 seconds left. Okay, let's see what other questions we have here. CBSE, yes, I'll include that in the last half an hour as far as the CBSE is concerned. See, mastering all the topics of JEE is not difficult at all. It just requires a lot of time and a lot of commitment. A lot of time and a lot of commitment, right? You cannot be slack for even 1 day or 2 days. You have to work hard for straight 2 years or 1 year, whatever amount of time you have left. If it is 1 year, then work really harder, right? If it is 2 years, then you have some time, but you cannot be slack for even 1 day, right? Okay, so let's everyone, about 6 seconds are left, right? Let's start the webinar. I hope all of you are able to see the screen. So this is a little bit about me. All right, in this webinar, we'll be talking about projectile motion and how to master projectile motion, right? I'll tell you how to do it. You won't be a master at the end of this, but you'll know how to do it. Okay. My name is Avinash Kumar. All those who are attending this webinar for the first time, my name is Avinash Kumar, and I've been a JEE expert and a career counselor for about 6 to 8 years now, on and off. Also, I have counseled more than 10,000 students, and I have directly taught more than 2,000 plus students, right? For JEE, I generally teach physics and chemistry. Okay. So this is more about me. I have done my BTech and MTech in biochemical engineering from IIT Delhi. I started in 2008 and I graduated. It was a 5-year course. Okay. So that is, that is all about me. I will share my contact information. That is phone number and email ID, WhatsApp number and email ID, not phone number. WhatsApp number and email ID at the end of the webinar. So if you have any pending questions which are left even after those half an hour, you can send me on WhatsApp. Right? I would prefer email or WhatsApp. Do not call. I generally don't answer phone calls. Is that fair, everyone? Okay. Fantastic. All right. So let's see. So this is our so this is our topic right here: how to master projectile motion. Right. So before I start this, I have a few questions that I want you to answer. Just to this is for me to know my audience. Right. First question is coming to you now. Which class are you in? Okay. I'll give you only 30 seconds for this. A very straightforward, question. Which class are you in? Right. And after that, I have just one more question. Yes, this is a live session, Atharva. I'm live right now. I'm, sitting in my house in Bangalore and I'm talking to you. It's 7:01 right now in 58 seconds. You have 5 more seconds to, answer this poll question. So far, 93% of the students have voted. Okay. I see a very, that's a good distribution. All right. So very few of you are 10 and below. So in the previous webinar, there were a lot of students who were 10 and below. That's actually good. So a lot of you are from 11th and more of you are from 12th. Okay. All right. So for all those who are in 12th, this is, I guess, very, very important. Also, I would like you to wait back after the webinar, because when I talk about how to start preparing, it will be divided into 2 parts, right? How to prepare in 1 year and how to prepare in 2 years. So for all those who are in 12th and for all those who are in 11th, it's very straightforward. But for all those who are in 12th, stay back for that, right? Very important. Okay. And I have just one more question, right? At what stage of preparation are you in? Whether you're in 11th or 12th, you are at some particular stage of preparation, right? So at what stage are you in? That is the question. And this should be a very instinctive answer. You shouldn't really have to think about it, right? Okay. All right. Uh, Yeah, so this is great. Very small number are, let me just share the results. So very small number of you are still wondering, which is fantastic. So at least all of you have decided that you want to prepare for J. This is, this is the first step in itself. Over here, you just have to keep, keep in mind just one thing. Once you have decided that you want to, prepare for JE, you have to make sure that from this day up to the first Sunday of April, of the year in which you are targeting JE, be it 2019 or 2020. First Sunday of April will be your JE main examination. So up to the first Sunday of April, there should be no slacking at all, right? Make sure that you concentrate only on studies and nothing else. That is the key. A lot of students are unable. So JE is very easy. A lot of students are unable to make it because the time required to prepare for it is long, and nobody is able to commit for that long. Okay. Right? And don't be discouraged by things like taking too much time to solve questions or getting too many incorrect. So these are things that every topper or everyone who succeeds faces. While I was preparing, I always, used to score like 55 percentile in my mock tests, right? So we had mock tests throughout the year, and in August, September, October, up to December, I was scoring only 50 to 55 percentile, which means there were 45% of the students in my institute all over India who were ahead of me, right? On the other hand, when JE actually happened, right, I was in the top, 4 of my institute, right? And the only difference, and I compared myself with all the other students. So all those who actually made it were all those students who were consistent for that 1 year. So I prepared in 1 year, right? All those who were consistent for that 1 year, right? There were people who were at the 80th percentile or 85th percentile in the beginning, right? And they didn't clear, right? So the key over here is consistency, very important. Okay. 55 of you have already started, again, fantastic. So once you've started, right, there will always be need for more and more guidance, and for that you can approach multiple people, right? We will have these free webinars, you can use that. We will have courses as well, you can attend that. There will always be need for more and more guidance. Seek that, but do not stop your preparation because of that, right? And all the 11% who have already started, and if you believe that it's going great, all the very best, right? I'm very sure that you'll succeed. Okay, everyone. So all right, last question, right? Last question, and this is only for 15 seconds, not more than that. How many of you have started studying kinematics? So all those who are in 12th and 12th plus, if you have started revising kinematics, go for yes. If you haven't touched kinematics after studying it for the first time in 11th, go for no. Okay, is that fine? All those who are in 11th, it's a very straightforward question. All those who are in 12th or 12th plus, if you have started studying kinematics again, then go for yes. Otherwise, if you studied it sometime earlier, maybe 8 to 10 months ago, go for no. Okay, all right. So enough polls. Let me share the results. 64% say yes, which is great. So out of 36% of the people who are, I am assuming a lot of you are in 12th and 12th plus, no problem. Just make sure that in your 1 year schedule, right, every week has 1 or 2 days defined for 11th standard practice. You won't get time later on, right? Every week, 1 or 2, days are for 11th standard practice, depending on how strong your 11th concepts are. Okay. And additionally, every month, you attempt at least 1 mock test on 11th standard syllabus. Okay, that is the key. I'll talk more about it in the end, but this is what you should definitely do. All right. Okay, now let's start with the session. Okay, so yeah, what is motion? Let's start with that. What is motion? So all those who have started studying kinematics, they would know, right? So motion is, I don't care about what kind of body I have, right? Whether it is a spherical ball or a cubical, solid or whatever it is. I don't care about the mass, the structure, all of these things. What I care about is what is the position of the body right now with respect to time and, the geography, and what is the position after a certain point in time, right? That is what I care about. And this is what we call kinematics. If that position changes, it means there has been motion. If that position doesn't change with respect to my frame of reference, right, in that case, there has been no motion in that frame of reference, right? This is basically what we know about motion, right? Okay. So if, let's say the frame of reference is me, and if, this has moved from here to here, the position has changed, therefore there has been motion. The study of this is what we call kinematics, right? How fast did it happen? So what was the velocity? What was the speed? two different things. What was the acceleration? Was it constant or variable? How much time did it? So all these questions, right? The answer to all these questions, we find that using kinematics. In this case, I do not care whether this is a pen or a pencil, whether it is black or blue or yellow. All these things will come later in laws of motion, right? Over here, all we care about is position and time and what is the change, right? So that is motion for you. All right, everyone. So now, if this is motion, right, to solve any kind of question in motion, right, this is what we need actually. Just give me 1 second. Yeah, so this is what you need to solve any question in motion. You need three equations, be it any dimension, be it 1 dimension, 2 dimension, or 3 dimension. We use only three equations. Have you ever heard of different equations for 2 dimension? Or maybe you might have heard that, okay, it's 2 dimensions, so maybe we have 6 equations. No, right? For any dimension, you only have 3 equations, right? 3 equations of motion that we use, right? There are constraints here, of course. The acceleration should be constant, and we use vectors here and so on and so forth. So these are constraints which are there, but we only have 3 equations of motion, be it any motion in any dimension, right? Now, I'm not covering 1 dimension here. I'm assuming all of you already know 1 dimension because you study about 1 dimension in 9th and 10th itself, right? So based on that, I have this question. Okay, based on that, I have this question. Yeah, so this is the first question that I have. Very straightforward question. Very, very straightforward question, right? A person is traveling on a straight line and he moves with a uniform velocity v1 for some time, and then with a different uniform velocity v2 for the next equal amount of time. Read the question very, very carefully. All right, everyone. That's the most important part here. So a person is traveling in a straight line and he moves from a uniform velocity v1 for some amount of time, and then he moves with a uniform velocity v2 for same amount of time, right? What is the average velocity? That is what we have to figure out here. Very simple question. I'm sure all of you would have already answered it. Just note down these expressions, because when I open the poll, you won't be able to see the question. So read the question very carefully at your end and note down these options. I will start a poll in 10 seconds. All right, everyone, work it out at your end. Okay. So launching the poll now. What is the average velocity v given by in this case? Should be a very, very straightforward question, right? There is no acceleration involved. You've been told that it's uniform velocity. 2 different uniform velocities, yes, but basically uniform velocity, right? So let's see how many of you get it. So this is, just me covering 1 dimension and other things in general using 2 questions. There'll be 1 more question after this, but this is what we are covering, right? So far, 80% of the students have voted and the poll has been open for 30. Okay, I'll give you 10 more seconds, not more than that. Okay, 10 more seconds. Yeah, we will take angle part very soon. Don't worry. Avishkar. All right. So far, 89% have voted. So let me share the results. A lot of you went for A. Very straightforward. Like I said, very straightforward. Okay. Right. I will explain this question in a very short while. Let me show you a different question. You will see that the options are exactly same here also. However, let's read the question very carefully. The question this time says that a person is traveling on a straight line and it moves from a uniform velocity v1 for a certain distance, and then it moves with a uniform velocity v2 for next equal distance. All right, everyone. Previous one was time. This time it is distance. That is the only difference. I'm explaining it over here. Remember, you won't get these explanations in the examination. Key point here, read the question very carefully, right? So a person is traveling in a straight line and he moves with a uniform velocity for some distance, and then with a different uniform velocity for the same amount of distance again. That is the question. Same options. What is the answer this time? All right. Once again, a poll for 30 seconds. And after that, we'll start with projectile motion. Okay, very quickly, everyone, what is the answer in this case? Just to let you know, both of these questions were taken directly from H.C. Verma. right? The most important book that you have in physics. Okay, all right. Uh, so I'm not taking questions right now because I'll take questions once we start projectile motion, right? Okay, 30 seconds. 72% have voted. Let me give you. All right. Let's 40 seconds. Let's close the poll now. This time we have a distributed thing, so not a lot of people went for A. C saw a higher proportion. Okay, now let's answer both of these questions and let's try to identify what is different in both of them. Okay, now this is what I feel most of you would have done, because after interacting with a lot of students, this is what most of the students do when they see this question for the first time. If you have seen this question earlier, okay, but if you've seen this for the first time, most likely this is what you did. Velocity is v1 in the first case, velocity is v2 in the other case. I want to find out average velocity, so this is my answer, and that is option number 1 over here, right? Okay, and so if this is what you would have done, if this is what you have done, you will probably get same answer in both the cases, right? You will get A in both the cases, over here also and over here also. All right, everyone. Now let's check out what is the actual process here. This answer is right in only one of the cases. It's not right in both the cases, right? And the way that we are solving it right now, v1 plus v2 upon 2, the way we are solving it is incorrect. That is not how we find average velocity, right? So let's go back to the definition here. What is average velocity, right? So that is trick number 1. Whenever you want to solve any JEE question while you are practicing, always go back to the basics. That is how you are being differentiated from someone who targets JEE main and someone who targets JEE advanced. Start from the very basic. Every question will be solved, right? So I see that I need to find average velocity. The very basic over here tells me that average velocity is defined as total distance, displacement, total displacement upon total time. Right, over here distance and displacement will be same because the motion is in a straight line in one particular direction only, right? So that is why it says uniform velocity, and hence I'm assuming same direction. So this is in one direction only in a straight line, hence it is one dimension, right? Anyway, this is the actual formula of average velocity. There is no other formula. v1 plus v2 upon 2 is incorrect unless you get it by this formula. So let's find out, right? So over here I have, let's say for time t, the velocity was v1, and then for same amount of time t, later on I have velocity v2. So what is the distance traveled in this case? The distance traveled in this case would be v1 into t, and the distance traveled in this case would be v2 into t, right? So total distance traveled, can I write that as v1 into t plus v2 into t? What about total time? Can I write it as 2t? So over here you will see that you are indeed getting v1 plus v2 upon 2. So in this case, yes, it is right. Okay, so all those who marked A here, yes, your answer is correct. If you followed this process, in that case, fantastic, right? But if you followed the previous process, then, well, you got the right answer in the previous case, but in this case, let's find out what answer you will get. So over here, we have traveled a distance of s with a velocity v1 and another distance again equal to s with a velocity v2. What is missing over here is time, right? Let's find out time. So what is time taken in this case? S upon v1. Time taken in this case, s upon v2, right? Once again, v average. What is total distance? 2s. Total time, s upon v1 plus s upon v2. Oh, I see something else. I don't see. Definitely this is not right in this case. Definitely, as soon as I look at this, I will straight away say that A and B are incorrect. A and B cannot be right. It is either C or D, right? Okay, now let's see. I have to basically rearrange this so that I get this part, right? Let me move this whole part over here and the average velocity over here. What do you get? I get S, let's take S common, 1 upon V1 plus 1 upon, V2 is equal to 2S upon V average. S gets cancelled and you get this. So in this case, C is the right answer. All right, everyone. But if you follow the basic concept, you will never be wrong. right? If you follow the basic concept, you will never be wrong. All the questions of JEE Advanced require you to follow the basic concept and have a clear understanding of that. They never ask you questions in which you can use a direct end formula. They ask you question in such a way that, if you have done the derivation, there is some modification in the derivation. If you're able to get that, you get the answer, otherwise you don't. That is the difference between JEE Main and JEE Advanced. That is the difference between people who get into other colleges and people who get into IITs. And we all know, how the careers and the future of two category of people change, right? So this is the key part over here. Right now, you have a lot of time to choose which one you want to be. Okay, everyone, I hope this is clear. So most important tip right now, first of all, read the question very carefully. That is like unsaid. And secondly, always start with the basic concept, right? After you've done like 50 to 100 questions, there will come a time when on reading the complete question, you will automatically skip 4 or 5 steps and reach the answer. So that is the short trick that you will realize on your own. This is not the time to learn short tricks, right? I will give you tricks for projectile motion now. Okay. So what are the basic steps which you can use to solve any question involving any number of dimensions in kinematics? This is the most important part of this webinar, and this is what we are going to talk about for the next 10 minutes, right? I give you 4 or 5 steps, right, which basically solve this problem, right? So see, this is where there's a reason why I came up with this, and as a generally I have this habit in which I find it very confusing if in a single chapter there are 5 conditions and each of those conditions have different formulas, right? In that case, I have to remember each of those different formulas, and I also have to remember in which case can I apply them. That's very confusing for me, right? I won't be able to score marks in that case. So my solution to that is find out the underlying concept over there, find out what works in every case, practice that a lot in every case, and then use that. So over there, I'm very sure that I will get the right answer. I may not get the right answer in 30 seconds, but I'll definitely get the right answer in 1 minute, which is fine, right? Which is fine, because if the choice is between accuracy and speed, I will go for accuracy first. Accuracy comes first. Accuracy means +4. Negative, I want to avoid negative marking, right? So accuracy comes first and then comes speed. So that is why this is how I came up with these steps, which if you apply to any question of any concept of kinematics, be it relative motion in 1 dimension, relative motion in 2 dimension, projectile motion, the normal projectile motion, or the projectile motion like this, or the projectile motion in this fashion, any kind of motion, if you apply these 4 or 5 steps, it will work, right? So let's find out what these steps are very quickly. First step, define the axis as per your convenience, whatever you are comfortable with, right? Over here, there is a side note. In some cases, the axis is defined by the question itself. The question tells you that, this is the horizontal and maybe your quantities are at some angle with the horizontal. So over there, the axis is defined for you, but still, you can still define your own axis. Keep in mind that later on, you will have to revert back to the axes of the question. That is one thing that you have to keep in mind. All right. So first step over here, define the axes. Let me explain that more clearly here. Let's say I have 2-3 quantities, random quantities like this, right? Now one axis could be, this could be, one axis, right? X and Y. Or what can you do other than this? Or maybe I can use one of these quantities itself as my axis. So let's say this becomes my X and the perpendicular to this becomes my Y. What is the advantage? What is the advantage here? In this blue case, right? In this blue case, none of my quantities, the one which is described by blue, none of my quantities are along the axes, and therefore I will have to resolve all the quantities. In this red one, at least one of them is something that I don't have to resolve, right? I will only need to resolve the rest of them according to, right, whatever angle that I can find out. So I will only need to resolve 3 of them, not 4 of them. So that is what you take care of. Point number 1, define the axes. in such a way that you minimize your effort. If that is different from what is given in the question, make sure that you revert back to it later on, right? Point number 2 is resolve all the quantities that you have, according to this axis. All the quantities, if you have velocities, if you have accelerations, if you have displacements, any vector quantities that you have in the picture, make sure that they are resolved according to these axes. That is step number 2. All right, everyone, I'll tell you how to resolve in a very short while, right? Point number 3 is very important, and this is where we make mistakes. So if you have understood point 1 and 2, right, you will have no difficulty at all. Point number 3 is where you will make silly mistakes, right? Point number 3 is where you will make silly mistakes. When we resolve quantities, it's very, very important to give them positive or negative. For example, right, in this x, in this red part, this is the positive x side and this is the positive y side, which means the opposite of that would be negative x or negative y. It's very important to take care of this plus and minus. For example, right, let's take this this vector p, right? So it makes an angle of theta here, right? And over here, this is the base part. So this is p cos theta. I'll tell you how it is p cos theta in a short while, but for now, just agree with me that this is p cos theta. Now this p cos theta is towards positive x-axis, so I'll make sure that I write a plus over here, right? This is p sin theta. Again, towards the positive axis, I'll make sure that I write a plus over here, right? Now over here, I also have another quantity, and right, this one, let's say this is q, and this makes an angle of alpha, right? In that case, if I resolve this, this is q cos alpha. And which direction is it at? It's in the opposite direction of x. I will write as minus. Why am I doing this? The reason why I'm doing this is because along a particular axis, I would know which quantities to add and which quantities to subtract, right? So if p and q both are velocities, then the overall velocity that I will have in this direction is p cos theta minus q cos alpha. This is what I will have. Okay, everyone, right? So that is the reason everything gets resolved in these two dimensions, right? You just have to take care of plus and minus here. All right, so this is minus q cos alpha, and this would be minus q sin alpha, right, everyone? Okay, and lastly, the last step is all those equations that we saw, the 3 equations, right? They only work in a single direction. They will only work in a single direction, right? And since now everything is in particular directions, apply those equations along each of those. You only have 2 directions now. Apply those equations along these 2 directions. This is the exact step that is followed to derive all those quantities that we derive for projectile motion, be it for inclined projectile motion, right, or normal standard projectile motion. These are the exact steps that you follow. So why don't we follow this step while solving questions itself, right? While solving questions and see how it works out. You will realize that it is easier to do this than to remember the formula every time. You will realize, I'll do this right now. You'll realize that it is easier to do this than to actually remember the formula every time, right? So let's see how this works. Before that, let's work on resolution of vectors. So these are the 3 equations that I was talking about. I'm sure all of you know this, right? And you can only apply this effectively if all these 3 quantities that you see here, V, U, and A in the first case, S, U, and A in the second case, all of these quantities are either parallel or anti-parallel. Only then you can do this, right? Everyone, otherwise you can't use these equations. If your U is here, if your V is here, if your acceleration is let's say here, you cannot apply this equation. You can only apply these equations if everything is along a particular direction, either on the same side or on the opposite side, right? So that is why we are following those 4 steps. We will revise again, but for now let's move on to how to resolve, right? How to resolve these quantities. Let's see. First of all, if this is your vector and these are the axes that you have defined, right? First of all, figure out what angle we are looking at here, right? It's very important to figure out the angle. Sometimes they make, so let's assume that this is vertical. Let's assume that this is horizontal, right? Instead of x and y, let me use vertical and horizontal. If the question says that the projectile, the body, the vector makes an angle of theta with the horizontal, this is the angle that you have. If the question says something else, if the question says that the vector makes an angle of theta or alpha with a vertical, then this is the angle that you're looking at. So point number one, make sure you pick the right angle. Right? That is very important. Now, once you have the right angle, after that, it's very straightforward. Okay. Just complete this triangle here. Right? Let's say this is, X and this is Y. All of us know, right? This is what we know. This is the base of the triangle. If this is theta, I will take this as the base of the triangle, right? Base upon hypotenuse is cos, right? So X upon P, let's say is the overall magnitude, will be cos theta. And therefore X comes out to be P cos theta. So this is where it comes from. Now, you don't have to do both of these steps every time. Instead, what you can do is, if this is P, then the then the vector along the base is always P cos theta. The vector along the height is always P sin theta. Just remember that part. Whatever is the angle that is defined, the component of the vector along the base of that angle is always cos. The component of that vector along the height is always sine. This is directly from the fact that cos is base upon hypotenuse and sine is height upon hypotenuse. That is where it comes from. Very straightforward, and that is the only thing that you have to remember. The only place where we make mistakes in this case is we are either unable to figure out the angle or we take an incorrect angle. That is the only place where you will make mistake. If you find the right angle, then this is not a problem at all. Along the base of the angle is cos, along the height of the angle is sine. Very simple to remember. All right, everyone. So resolution of vectors. Let me now show you what we are talking about. Right. So once again, I'm going to take some random. Let's say this is the axis that you have, and I've taken 3 quantities. Let's say this is 1. This is 2, and let's say this is R, right? The third quantity. So I've taken 3 quantities. We will resolve all of them, right? Now, if you have these 3 quantities, it would be very difficult to apply the equations, and therefore you will figure out some axis. In this case, I would probably want to figure out this axis, but for now, since we are practicing resolution, let's stick to this. So some particular angle will be, all the information will be given to you. They may say that angle P, vector P makes an angle of theta with the horizontal, vector Q is perpendicular to vector P, right? And vector R makes an angle of let's say alpha with the negative side of horizontal. Let's say this information is given to you. This is the information which is given to you, right? Okay, everyone. So vector P makes an angle of theta with the horizontal. I've taken X as the horizontal. This is the positive X part. This is the positive Y part. Therefore, this would be negative Y and this would be negative X. Right? So this is what we have right now. So what is the first step? Identification of axes. We have done that. What is the second step? Resolution of everything along those axes. So let me resolve this. This comes out to be P cos theta. Remember, this is theta. So this is the base, and therefore I will have cos over here. This part is P sin theta. I will actually write it along the axis. So this is P sin theta. So far so good, everyone, right? This is P sin theta, and you'll have the same value here as well. So this is P sin theta, right? Second part, right? If this is 90 degree, right? If this is 90 degree, remember, if this is theta, can I say this is 90 minus theta? You will have to apply a lot of geometry over here. So if this is theta, can I say this is 90 minus theta? Because the angle between two axes is always 90 degree, right? So if this is theta, this is 90 minus theta. This whole thing is 90 degree. If this is 90 minus theta, can I once again say that this has to be theta? Right? So values will be given to you. You have to figure out the relevant value for yourself. In this case, this is now my base angle, right? Q makes an angle of theta with Y axis. It was not given directly, but I was able to figure it out. Okay, let's see. So can I say this part right here? This is Q cos theta. The angle is still theta. and this is the angle, so this is the base now, right? If this is the angle, this is the base now. So Q cos theta, and this is the height of this triangle. Remember, this is the angle, so this is the height of the triangle, and this is the base. So this value right here is Q sine theta, right? Also, this Q sine theta is along the negative x-axis, right? From here it goes in this direction. So do I write Q sine theta or do I write minus Q sine theta? The answer is I write minus Q sine theta, otherwise it is wrong, right? I have to write minus Q sine theta, otherwise this is incorrect. Okay, so point number 1, make sure your angles are right. Point number 2, take care of plus and minus. All right, last quantity is R. Over here it is straight away given to me that the angle over here is alpha. So this would be R cos alpha, again on the negative side, so minus, and this is R sine alpha. This is also on the negative side, so minus. Now what does the picture look like now? Now I have quantities which look like this. So over here I have Q cos theta. Over here I have P sine theta. Right, over here I have P cos theta. Over here I have minus Q sine theta. Somewhere over here I have minus R cos alpha and minus R sine alpha. So do you see all the vectors which were in some random direction are now aligning along two axes only? What is the next step? Just pick this separately and pick this separately. Very simple, problem solved. Is that fine, everyone? So that is all it takes. That is the reason why we are defining axes and resolving them. If you get that part right, everything is very straightforward. All right, everyone. So practice resolution of vectors, very important. And then after that, I'll tell you what to practice. But let's move on to projectile motion. Right, so we will use this concept. We will practice this concept again and again repeatedly now. If you haven't really understood it completely for now, don't worry. We will do this again and again at least 2-3 times today. Right, so by the end, you should definitely know this. Otherwise, well, you will have the recordings and you will have my contact information, right? So now, this is a typical projectile motion that you see in front of you. This is what we call a typical projectile motion. This is not the only projectile motion that we have. Anything, what is a projectile? Something which is projected is a projectile. Something which is projected at some angle is a projectile. So I can project things at any angle. Right? If I project something vertically upward, this is also a projectile, and over there we take it in motion in one dimension only. Why? Because it goes up and it comes down. But that is also projectile motion. Right? That is also projectile motion. If you throw something straight upwards, that is projectile motion. You can throw it straight upwards from the ground. You can throw it straight upwards from a height. Right, and then maybe it comes back to the ground. There could be any number of cases over here. Right, there could be any number of cases over here. Maybe you throw something from the ground and somebody catches it in between. Right, there could be any number of cases in this scenario. So first major scenario is you project something straight up. Right, okay, so that is something that is what we consider as motion in one dimension only. There is one more case. You project something straight and it is along the ground. This is your motion in straight, motion in straight line. But what if I project something straight but from a height? What will happen in that case? It will come down eventually. Right. So this is the second big scenario of projectile motion. Right. You project something horizontally but from a height, so it comes down. That is the second scenario. All right, everyone. Okay. There is a third scenario. This is the third scenario right here, in which you project something at an angle, right? You project something at an angle, right? So it comes back to the horizontal ground after some point of time. There could be one more special case where, let's say you project something at an angle from a height. Over there, it will come down at some farther distance. So these are two more cases. So these are so many different cases over here. Question number 1, do we study all of these cases separately? Or can we treat all of these cases using the steps that I just gave you? Everyone, the question is very straightforward. Do we study all of these cases separately? Let me, learn the formulas for all of them separately. Let me derive all those formulas separately. Do we do that? Or let's just make sure that all the steps that we have studied, can we apply them in all of these cases? Does it apply in all of these cases? Let's see that, right? If that works, then I don't need to do, I don't need to remember complex formulas at all. Because the reason why most of you have issues with inclined projectile motion is because it has a certain complex formula. I will show you that it is the exact same formula that you get in the normal projectile motion. It's the same formula. There's no change, right? I'll show you that in a very short while. So everyone, these are all the varieties of projectile motion. Once again, let me show you, right? This is the first one. You project something straight up. It can be from the ground or it can be from the height. This is the first scenario, right? The second scenario is that you project something straight horizontally, right? And in that case, it comes down. Okay. And the third scenario is what we saw just now, in which case you project something at an angle, it eventually comes down. Over here, you could have a special situation in which you do project something from a height, but still at an angle, and therefore this is what happens. Right now, the reason why I've broken it down into all of these cases is because let's see what we can do here. Over here, right? Let's say in all of these cases, my axis is this. Horizontal is X and vertical is Y. Let's say in all of these cases, right, everyone, these are my axes. Horizontal is X and vertical is Y, right? Let's take a very normal case, right? So in this case, all we have to do is in every case, we have to figure out what are the values along X and what are the values along Y. And if there is something in between, we have to resolve it, right, everyone? So let's take this particular case, very straightforward. In this particular case, you will have a certain velocity in Y direction, right? You will have certain velocity in Y direction. Let's call it U, the initial velocity that you projected with. Is there any velocity in the X direction? No, right? You're projecting everything straight up. There is no velocity in the X direction, right? Is there any acceleration in the X direction? No. There is no motion in the X direction at all because there is no velocity and there is no acceleration. So there will be nothing else. There will be no displacement. There will be no final velocity, etc., etc. So over here, I will just have an AY, which is basically G, right? I am taking this as positive Y, therefore this is minus Y. G is downward, so I have to write it as minus G. Very important, keep that in mind, right? These are the values that I know. I will be given one more stuff over here, right? And I can figure out the rest of the things. For example, let's say you want to know for how long will the projectile take to reach the top. Reaching the top means it cannot go any further, which means the final velocity Vy is 0. So some extra information will be given to you using which you can find out the unknown, right, everyone? Okay, let's take this scenario. In this scenario, once again, right, is there any initial velocity in Y direction? I have not, projected it along Y direction at all. I have projected it along X direction. So there is no initial velocity along Y direction. There is initial velocity along X direction, whatever initial velocity you projected with, let's say that is U, right? Is there any acceleration along X direction? Obviously no. Is there any acceleration along Y direction? Yes. This is still minus G. So the body has no velocity along Y direction, but it has acceleration. So it will start moving along that direction, right? Okay, so I'm sure you can find out Vy over here. And I'm sure you can find out Vx over here. And given certain things, you can find out the rest. For example, maybe the height is given to you. Maybe it is given that you are projecting horizontally from a height of 50 meters. So Sy or displacement in Y direction is given to you, right? And this displacement is, by the way, downward. So I will write minus H. Remember, I started my axis from here. So the displacement is minus H, right? So things will be given to you. Just make sure that you resolve them in the X and Y direction, right? You add the right positives and negatives and then apply the equation. So I will apply equations of motion separately over here and separately over here. Over here, it is a uniform motion. You will see that there is no acceleration. So X, along the X direction, there is just uniform motion, nothing else. Along the Y direction, there is accelerated motion. So I will apply equations accordingly, right, everyone? So this is basically what I'm talking about. Whatever is the situation, right? All you have to do is figure out the axis, resolve everything along those axes if it is not resolved already. We'll come to a case right now in which the things are not resolved. So over here, the velocity is u and the angle is theta. So this is not resolved. We'll come to this case right now, but treatment of these two cases tell you that all you have to do is make sure that you figure out the axis, resolve everything along the axis, and apply equations along those axes only, right? Okay, so this is what we are going to do. This is what we are going to do for projectile motion now. All right, so yeah, I'll come to this slide in a short while. So this is basically what you have in projectile motion, right? You project something with a velocity u, the angle is theta. So if you resolve it, the horizontal, remember this is theta, this is the base of theta. So the horizontal component is u cos theta. Vertical component is uy is u sin theta, right? So along x and y direction, you have the initial velocity, right? Ux is equal to u cos theta and uy is equal to u sin theta, right everyone? Let's check out other quantities. Is there any acceleration anywhere? Yes, there is a gravitational acceleration acting downwards. There is a gravitational acceleration acting downwards, which means it is only along y-axis, no need to resolve. Ay is equal to minus g. What is ax equal to? Nothing. There is no acceleration. So 0. All right. So these are the quantities that we are aware of. These are the quantities that we are aware of. Now, whatever question is asked after this, let's say they ask you what is the horizontal velocity after, once the projectile starts making, and so let's say the initial angle of 60 degrees. What is the horizontal velocity when the projectile makes an angle of 45 degrees? You realize that the horizontal velocity is not changing at all. So whatever was the horizontal velocity at this point of time, you will have the same horizontal velocity here as well, right? What is the vertical velocity when the projectile is making an angle of 45 degrees? Well, you know that Vy in that case would be, Vy in that case would be, sine 45 degrees. Sine 45 degrees, whatever was the V into sine 45 degrees, right? So this is how you can treat any question separately just by using the basic concepts, right? We'll solve a question using this before we actually move on to the formulas, and you'll realize how easy this is, right? So this is what we have discussed so far. Whatever is ux, that's u cos theta. Uy is u sin theta. There is no acceleration here. There is minus g acceleration over here. Whatever is the displacement along x-axis, we call that sx, and this is what is known as range of the projectile. What is the displacement? Whatever is the displacement, so the maximum displacement is what we call range, right? Maximum sx is what we call range, right? Maximum sy is what we call height, maximum height. Okay, and well, time taken is the time during which the projectile was in the air. Very important point, the time during which the projectile was in the air, which means what? Which means the time of flight is only, if I say only along y-axis, the time of flight is when the Vy goes from u sin theta to 0 and comes back to this. That is basically time of flight, no change, right? That is basically time of flight, no change. Let's see how that works out, right? Let's see how that works out. So before we come to this case, can you tell me the time of flight for this motion? Something went up and came down, right? The initial velocity that it went up with was u, right? What is the time of flight in this case? Can you just tell me that part? The time of flight would be very simple. So initial velocity is u, right? Acceleration is equal to minus g, right? And displacement, I need one more quantity. Displacement over here is 0. It went up, it came down, so displacement is 0, right? I know initial velocity, acceleration, and displacement, so I have to use, and I want time, so I have to use second equation of motion. That is how we figure out, right? So I have to use second equation. Let's do that. S is equal to ut plus half at square. So 0 is equal to u into t. We have to figure out what t is, right? Plus half into minus g into t square. Right, I can take, let's take the LCM and everything. I get 2u minus g t right? This is what you get, everyone. I hope all of you agree with this part. Everyone, this should be very clear. All I've done is taking the LCM, right? And then, plus minus becomes minus and so on, right? Once you simplify this, what is time of flight? Time of flight T comes out to be 2u upon g. I need you to remember this part. T is equal to, only for the next 5 minutes. Just remember this part only for the next 5 minutes, right? So T is equal to 2u upon g, right? This is the time of flight when you project something straight up and it comes down. Now let's come to projectile motion, right? Let's find out what is the time of flight in this case. Okay, so this is my u here, right? The angle is theta. So therefore, time of flight is defined as the time spent in the air, which means when the motion in y direction ceases. The motion in y direction will cease when it hits the ground again, which means the total displacement along y should be 0. Everything is, just compare everything with what we just did, right? So what is the initial velocity? Uy is equal to u sine theta, right? Ay is equal to minus g, right? And sy is equal to 0. I need the time of flight here, right? Exactly same thing. This is what we have done. Sy is equal to u sine theta into t, where t is the time of flight, right? And what do you get here? And what did you get previously? Previously you were getting 2u upon g, right? The time of flight for vertical motion was 2u upon g, right? So do you see, this is the exact same formula. Since u changed, earlier the entire u was along this axis, so your formula was 2u upon g. Now your u is along some axis, so vertical is u sine theta. So formula is exactly same. Whatever is the vertical velocity, that multiplied by 2 upon g. Do I need to remember this formula? No, I can always do this, right? I can always find out what is the initial velocity, the acceleration, and I can apply this equation. I can do that at any point of time, right? So projectile motion is not a different type of motion. It is just a motion happening in 2 dimensions simultaneously. I have to treat those 2 dimensions separately. That is all I have to do. I have to treat both of them separately. There are few things which should be absolutely clear. For example, the definition of range, the definition of height, and the definition of time of flight. The definition of time of flight is for as long as the projectile stays in the air. Whether you do this, or you do this, or you do this, anything, as long as it stays in the air, right? So this time of flight is only applicable for this part. What about this case? Will you get the same value? No. You will not get the same value, right? So over here, your Sy will basically be, instead of 0, you will use minus h. In this case, you will use minus h and you will figure out the time. So whatever be the case that is given to you, all you have to do is figure out these quantities and then apply the equation of motion. Therefore, my final question, do you really need to remember the formula? No. Do you even need to remember the derivation? Not really. You need to practice the derivation enough number of times, but you don't need to actually remember it, because we are following the exact same step everywhere. All right, everyone. So this is what we are talking about. Now I will apply the same thing to inclined as well. Let's take it even more. Let's make it even more complicated, right? So I've told you about this. I've told you about this. Now we are going to talk about this, and I will show you that this is the exact same formula that you will get over there as well, right? So let's talk about that. Just give me one more point. Whatever is whatever time it takes to go up, same as the time that it takes to come down, right, everyone? So in the vertical scenario, it was u upon g. U upon g is the time taken to go up, and u upon g is the time taken to come down. Total is 2u upon g. Over here also you get the same thing, right? The time taken to reach the maximum height is 2u u sine theta upon g. Time taken to come back to the height is again u sine theta upon g. All right, everyone. Time of ascent is equal to time of descent. Very straightforward. Okay, so these are things that very by common sense itself you should be aware of. Now let's apply, forget the formula. This is anyway something that you can't really do by the formula. Over here, you have an aeroplane which is flying horizontally at the height of 490 meters, right? So this height right here is 490 meters, right? and the velocity that you have over here is 180 kilometers per hour. Obviously, it releases an object, and that object lands on the ground. So over here, we want to find out where does the object land and after what amount of time. Apply the concepts that we just studied and tell me which one is right. Okay, apply the concepts that we just studied and tell me which one is right. I'll be back in a very short while. All right, everyone, I'm back. Wasn't much of a gap, actually. But let's see, everyone. So the question is very, very straightforward. Like I said, right? This is a case of this kind of motion. As you can see in the GIF itself, it's a case of this kind of motion. We just want to apply that exact same concept and want to figure out what the right answer is. Remember, we haven't really done the the range part yet, but even then you will be able to solve this question if you just apply the same concepts. Okay, let's see. Let me just release the poll first, right, to see how much you have done this, and then we'll answer this question. All right. So you have the poll in front of you now. And after this question, we'll work on, projectile motion in an inclined plane. After that, I have a very small surprise for you, and then we will continue the webinar. All right, everyone. So I'll keep it open for another like 5 more seconds, even though very small number of you have voted so far. But even then, let me keep it open for like 5 more seconds. Okay. And by the way, for all the questions that I'm not taking, I'll stay back for another half an hour and we'll fix those, we'll answer those questions. Let's see. Okay, so a lot of you say B. Let's find out what the right answer is. Okay. Now, remember, we want to do the exact same treatment, right? So when the object was released over here, let me divide everything into X and Y, into X and Y axes. So along the X axis, is there any initial velocity? Whatever was the velocity of the plane, that is the initial velocity along X axis, right? And there is no, we are ignoring air resistance and all of those things. So Ux is 180 kilometers per hour, right? Right? Okay. What is Uy? The object was just dropped. When you say that the object is dropped, it means that you're not giving it any velocity, you're just releasing it, which means Uy is 0. All right. Is there any acceleration along X-axis? I'm ignoring air resistance. Therefore, there is no acceleration along X-axis. Right. Is there any acceleration along Y-axis? Absolutely. It's minus G. Right. Okay. Now, first of all, I want to find out time. I don't want to find out where it lands first. Why? Because where it lands first is basically Sx. For Sx, I need the time. So I will basically try to find out time first, and then I will move on to finding out where it landed. Okay. All right. So I need one more information here, and that is given, as you can see. So Sy is minus 490 meters. Right? Sy is minus 490 meters. I will again apply, I want time, right? So I will apply second equation and I will figure out what the time is. Once you apply second equation, you will be able to figure out what the time is. In fact, Uy is 0. So that makes things easier. I'll show you the solution in a short while. Once I have time, right, to find out Sx, there is no acceleration. So just Ux into time will give me Sx. That is how you solve this question. No formula required. And this is the question of projectile motion. All right, everyone, this is a question of projectile motion. This is the solution right here. Okay. So minus h or minus 490 is equal to, half into 9.8 into t square. All right. So basically, once you, simplify this, you will get t as 10 seconds. All right, everyone. And if you use the 10 over here, right? This is 180 kilometers per hour. All the units that I have used over here are in meters or seconds. Therefore, I need to convert this. This will come out as 50, right? This will come out as 50. Basically, you divide it by, multiplied by 5 by 9, right? Everyone? Yeah. Okay, so basically I will have 180 into 1000 upon 3600. Just confirming, everyone. Yeah, so you will have 5 and 5 by 18. Okay, now this is fine. So yeah, I will get 50. So 50 into 10, 500 meters. All right, everyone, very straightforward. No formula required. All I've done is used equations of motion. So do you really need to remember 3 or 4 or 6 different formulas, or can I make do with 3 equations? Right, 10 seconds and 500 meters. B was the right answer over here. Right, B was the right answer over here. So let's see how this works in projectile, when the projectile is on an inclined plane. Let's see how that works, and then I'll give you that surprise. Okay, everyone. So remember, we are following the exact same steps. We are following the exact same steps. So I have a projectile which is again launched at an angle of u, and the at an angle of theta with a velocity u. However, there is a inclined plane in between, and that inclined plane makes an angle of beta, let's say. Right. So what do I do? To make things easier, I will define this as an axis in itself. This is my usual axis. I'll make this as my new axis, and the perpendicular of this would be my y-axis. So this is plus x and this is minus y. Now all I have to do is resolve everything. See, anyway you were resolving u, right? Anyway you were going for u cos theta and u sin theta. This time you will go for what? How much is this angle? What is this angle? So this is actually alpha over here as shown. So let me take this as alpha, and this angle is alpha minus beta, right? Let me take alpha minus beta as theta this time. So this is still u cos theta. This is u sin theta. So everything is still the same. Everything, all the treatments, all concepts are same, right? Let's check out one more thing. Your acceleration is like this, right? Vertically downwards. Now my axis is not this. Now my axis is slightly tilted. So I have to resolve the acceleration as well along these axes, right? So this is beta, right? This is 90 degrees, right? Which means, can I say this is 90 minus beta, right? This is also 90 degrees, right? This angle is also 90 degrees. So can I say this is beta? So if your inclined plane makes an angle of beta with a horizontal, acceleration, gravitational acceleration will make an angle of beta with a vertical, and we need to resolve that, right? So I will get g. So this is beta, right? So I will get g cos beta over here and g sin beta over here. This is minus g cos beta and this is minus g sin beta, right? Now keep these values in mind, right? Keep these values in mind, and I will show you the formula. Right, I will show you the formula. Yeah, now check out this formula. 2u sin alpha minus beta upon g cos beta. What was the formula in the first case? The formula was 2u sin theta upon g, right? What was the formula before that? It was 2u upon g. So do you see anything changing? I don't see anything changing. This is the component of velocity along the y-axis. We are always using that. The component of velocity along y-axis. Every time it is that. This is the acceleration along y-axis. I'm only using that, acceleration along y-axis. So nothing is changing exactly. You have to follow the exact same treatment. I'll show you the derivation as well, which follows the exact same process. Right. So let me do the derivation over here in front of you rather than showing it. So let's see, along the x-axis, what do you have? Ux is, remember, alpha is the angle between this, the initial velocity and horizontal, and beta is the angle between the inclined plane, right? And I have taken alpha minus beta as theta, right? So this angle is theta right here, just to make things simple. So ux is still u cos theta. In bracket, I'm going to write u cos alpha minus beta. right? The uy is still u sine theta, right? Or u sine alpha minus beta. Right, everyone? Are you all getting this? So in an inclined plane, this is how it works. Everything works out exactly the same way, right? Ay is equal to, right, g cos beta minus g cos beta, as we just saw earlier, right? And therefore, what is the time of flight? Right, the time of flight is when it hits back on the inclined plane. So displacement along y-axis has to be 0. Sy is 0. Apply the same concept again. S is equal to ut plus half at square. So 0 is equal to u sine theta, right? U sine theta into time plus or maybe actually minus, let's skip a few steps, minus g cos beta into t square upon 2, right? Once when you simplify this, this is what you will get. Time is equal to 2u sine theta upon g cos beta, right? Or we can replace theta with alpha minus beta, and you end up with what you were looking for. All right, everyone. So again, this is what I basically want to prove with this webinar, that all you need are the 3 equations of motion, whatever be the question. You will never get those standard questions. So you don't need to remember this formula ever, right? You don't need to remember this formula ever. You will never get a standard question like this, right? You will probably get a question in which they want to find out that what is what exactly is the velocity at when this makes some particular angle with the horizontal or some particular angle with the inclined plane. So you anyway have to break it down into those steps. So why not practice that rather than spending time on learning this formula? Not required, right, everyone? So this is how you treat projectile motion in an inclined plane, and we treat it in the exact same way like everything else. All right, and for all those who have been with us, this is the surprise that I have. The webinar will continue. We will find out the range and height in the exact same manner, but this is the surprise that I have for you, right? So if you want to study more about all of these concepts, you can join a trial at something as low as ₹99, in which you will get 6 free classes. I'm calling it free classes because this 99 is refunded back if you don't like those classes. Right, so at just ₹99, you enroll and you get 6 free classes. Along with that, you are added to a WhatsApp group where your doubts are resolved by people like me, right? Your doubts are resolved instantly by people like me, right? So you have teachers like me who take your classes and then basically clear your doubts. Okay, and if you decide to join this at the end of that 1 week, right? In that case, you'll be broken down into smaller batches and your classes will continue. So just copy paste this. It's very straightforward. Tiny URL/JE11 course or JE12 course. For 1 year, go for JE12. JE12 is a 1 year course and JE11 is a 2 year course. So all the droppers also can go for JE12, right? Also, only one more point that I want to highlight here. Once you come to this page, do not click on pay 1,000. 1,000 is the usual price of joining a trial session. 1,000 is also refundable, but instead click here. Click on avail now. That's very important. Right, click on avail now, so that way you'll have a reduced price of 99 and not 1,000. Huge difference, right? So once you go here, scroll down and figure out what your schedule is going to be, what exactly are the things you'll be getting, right? So figure out all of these things, right? And then, so this is for 2 years, this is for 1 year. You get all the information about course structure and batches and material that you will get, right, on these pages. All right, remember to click on avail now and not over here. This is, if you click here, you'll have to pay 1,000. That is the difference. So if you want to join the trial sessions of 6 classes, right, click on these links and click on avail now. All right, moving on to the next part of the webinar, we are going to talk about maximum height of the projectile, right? And let's figure out what the maximum height is again by using the exact same concept, right? Okay, so remember, if I want to find out maximum height, I only need to figure out the motion in y dimension, right? So let me just write down y at this point of time. Uy is my u sine theta. I don't even need to draw the diagram. Now I know this. So this is the benefit of solving questions multiple times. You kind of you are able to figure out things on your own, right? So uy is equal to u sine theta, ay is equal to minus g, I'm taking the usual projectile motion over here, not the inclined one. We'll come to the inclined one, right? And we want to find out maximum height. Now, when does the projectile reach maximum height? When Vy becomes 0, right, everyone? So just do that. And what do you get? Okay. Which equation do I need over here? My first question is, which equation do I need over here? I want to find out the maximum height, which is basically Sy, the displacement. This is what I want to find out. So once you see these four quantities, right, the third equation comes to mind. V square is equal to U square plus 2As, right? So 0 is equal to U square sine square theta plus, or rather minus 2 into G into whatever is the height H. And therefore your height H comes out to be U square sine square theta upon 2G. Now, can you do this exact? So this is the formula. If you want, you can remember it. Like I said, you don't need to remember it, right? However, can we derive the same thing for inclined as well? Can we do the same thing for inclined as well? That is my question. Let's see. So in the inclined case, what will happen? Y, X, right? This is beta, and this is the projectile U, right? My G is downwards. So far I figured out that along the y-axis it is minus G cos beta, and this is minus G sine beta. These are the things that we have figured out until now. Now let's figure out what the height is in this case. Height will once again, height above the inclined plane will once again be the same thing, right? If I want to find out the height along the inclined plane, I'm looking for Sy, right? So Sy once again is if I want to find out Sy, once again I'll have to apply the third equation. Let's figure out. So Uy is equal to U sine theta. Remember over here theta is equal to alpha minus beta, where alpha is this angle, right? Ay is actually minus G cos beta, right? So what would be Sy over here? Okay, Vy, will Vy be 0? Everyone, in this case, will Vy be 0? That is the question that I want to ask. If you answer this question, this is finished. So let's see. This is the maximum height, right? So vertical height will not be 0. Horizontal height will not be 0, but the vertical velocity or a horizontal velocity will not be 0, but velocity along y is obviously becoming 0. So Vy is still 0, which means everything remains the same, right? 0 is equal to U square sine square theta, right? Minus 2G cos beta into whatever is, let's call it H again, whatever is the H. So what does H come out to be? H comes out to be exact same thing, right? U square sine square alpha minus beta upon 2G cos beta. I hope all of you are understanding what I'm trying to show here, right? These derivations are not important. The idea behind these derivations are important, because you can always do these derivations by yourself. If you understand the idea, if you get the idea, you will be able to do the derivation by yourself, right? In fact, let's do one thing. Let's replace the quantities that you have over here. So, right, my initial velocity was U sine theta. So I was getting U square sine square theta, right? If my velocity is U sine alpha minus beta, what am I getting? I'm getting U square sine square alpha minus beta. As simple as that, right? My acceleration was G, so I was getting 2G. My acceleration is G cos beta, so I'm getting 2G cos beta, right? So actually you don't need to remember stuff. In fact, remembering one formula is sufficient. You can just plug in the values of the other formula. This is as straightforward as it can be. Okay, but remember, you will never get questions directly on formula, and therefore this derivation, this entire exercise is very, very important. All right, everyone, this exercise is very, very important. Okay, so this is how you treat maximum height. All right, this is how you treat maximum height. So you get H is equal to U square sine square theta upon 2G. For an inclined plane, you will get U square sine square alpha minus beta upon 2G cos beta. All right, everyone. Very simple. Okay. Now let's move on to the last part, which is the horizontal range. Now horizontal range is my favorite part. Why? Because in horizontal, to figure out horizontal range, I have to check out the motion along x-axis, and along x-axis there is no acceleration, at least in the standard projectile. So along x-axis, ux is equal to u cos theta, right? Ax is nothing, and therefore sx is just ux into t, or u cos theta into 2u sin theta upon g, or you can get 2u square sin, 2 will be removed. I hope all of you know a little bit of trigonometry. U square sin 2 theta upon g, right? This is called range, the maximum displacement along x-axis, right? So u square sin 2 theta upon g, this is what you can get. If you don't want to use the time, if you want to use the height, you can use that as well, right, everyone? Okay, but this is easier. You can figure out the time, and using time you can figure out the range. And this is the exact same thing that we did in that plane question as well. We figured out how much time it was in the air, and then we figured out how much distance it could have traveled horizontally in that much amount of time, because once it reaches the ground, it is not moving. That is my assumption. Okay, so range is this. Can I do this along the the inclined plane as well? Yes, I can. Now over here, if I were to apply, so my R is u square sine 2 theta upon g, right? Now if I were to really substitute the values directly, will that work? Is the range along an inclined plane u square sine 2 alpha minus beta upon, I don't know, g cos beta? Is this the right formula? Let's derive and find out. So remember, in this case, I had no acceleration along x-axis. So in an inclined plane, in the case of an inclined plane, right, I have minus g sine beta as the acceleration along minus x-axis, right? So ux is u cos theta, where theta is alpha minus beta, right? Ax is there this time, and this is minus g sine beta. But does it change anything? No, it doesn't, right? I mean, all I have to do is still have to find out Sx, which will be given by ut plus half at square. Just have to apply this formula, and that is my answer. This doesn't change anything. There was no acceleration earlier. This time there is acceleration, right? So just substitute the values, and you will get your formula. U cos theta into the time of flight was 2u sine theta upon g cos theta, g cos beta, plus half of sine beta into 2u 4u square sine square theta upon g square cos square beta, right? So just simplify this and you will have your answer, right? My point is, do I need to simplify this? In an actual question, I would have figured out what is u cos theta. In an actual question, I would have figured out, I would have actual values of this. So why won't I just multiply this and figure out? Why will I, make this complicated calculation, figure out a complicated formula and try to remember that? I don't need to, right? All I need to know is that I just need to apply this equation. So that is the whole point of this webinar, everyone. So just summarizing, yeah, so this is your final range, right? There's just one more point that I want to add. Yeah, that one point is that you have the maximum range in this case when theta is equal to 45 degrees. Your maximum range is given by u square upon g, and that is when theta is equal to 45 degrees. Also, you get the exact same range for complementary angles, right? You get the exact same range for complementary angles, and the reason for that is trigonometry. Okay, for 30 degree you will get the same range as 60 degree. Why? Because 30 degree for value of 2 theta for 30 degree is 60, value of 2 theta for 60 degrees is 120. Both of them have the same thing, right? So 2 points, one, complementary angles give you same range, and two, your theta, right? For theta is equal to 45 degree, you have the maximum thing. I have a small game for you. that I really want you to figure out. I hope all of you are able to see the screen. So over here, right, you can, so this is a small game in which you have to hit this part and you can keep on modifying this. So this is the range, right? You can keep on modifying this. Let's keep it at 20 meters. And you know, in that case, if I want to hit this, what should I do? So for 18 velocity, what should be the angle? Right? So just play with this game and you'll be able to, you know, figure out a lot of things. Okay, a little bit. I only got 1 star. So let's change this slightly. Oh, perfect. 3 star. Right? So this is a small game. There isn't, the other things are you can actually change this as well and you can make it into a horizontal, you know, horizontal projectile. Okay. So just play with this game. I'll give you this link in the, you know, along with my contact details in a short while. Right. So that is what we have for projectile motion. This is something that I just told you. Complementary angles give you the same range. Right. Now moving on, let me see how much time we have. Okay, we have about 10 minutes. So you know, let's do one question and then I'll start taking your questions. Is that fair, everyone? Let's do one question and then I'll start taking your questions. So this is a you know, question that we have. A gun fires 2 bullets at 60 degrees and 30 degrees with the horizontal. The bullet strikes the same horizontal distance. We know that already because these are complementary angles. That is a useless piece of information. The question is, what is the ratio of maximum height of the 2 bullets? Now, these are questions that you would expect in BITSAT, in JEE Main as well. Yes, definitely. Right. In all your state examinations, you know, MHCET, KCET, right? EAMCET for Telangana and, you know, Andhra. Right. So, you know, WBJ. So all of these states, VIT. So all of these examinations can have questions like this, very straightforward questions where you can directly use the formula. But since you have practiced those questions so many times, you will automatically remember the formula. For example, I do remember that H is u square sine square theta upon 2g. And the angle is 60 degree and 30 degree. U remains the same for both the cases. G remains the same for both the cases. So if I want to find out the height, what should I do? Let's find out. So raising the poll, I hope everyone has noted down the options. Okay, everyone. After that, we'll solve this question. I'll give you one more question, then I'll start taking your questions. So the second question that I'll give you, that is homework. All right. So let's see. We're getting mixed reviews. I will stop here. Right. Let me share the results. So we have mixed distribution. Let's find out what the right answer is. Right. Okay. So over here, I see that U and G will be same for both of them, right? So if I want to find out H1 upon H2, I need to find out the ratio between sine square theta 1 and sine square theta 2, right? Or I need to find out the, you know, the ratio of sine square 30 degrees and sine square 60 degrees. Sine square 30, sine 30 is 1/2, so sine square 30 will be 1/4. Sine 60 is √3/2, so sine square 60 is 3/4. I believe you'll get 1/3. B is the right answer. All right, everyone. So very straightforward question. Okay, this is the next question. At what angle of projection of a projectile? At what angle will the maximum range be twice the maximum height? This is again a question which can be directly solved using the formula itself, right? So you know, your maximum height is u square sine square theta upon 2g, and it is given that range is twice the maximum height. Okay, range is twice the maximum height. So range is u square sine 2 theta upon g, and you know, this is half. Things will get cancelled, and therefore if you want to find out the angle, we have sine square theta is equal to sine 2 theta. Just solve this and you will have your answer, right, everyone? So these kind of straightforward questions are asked in most of the examinations, right? But if you follow the process that we just discussed, you will have the basic understanding of everything. You will be able to solve advanced level we are unable to do advanced level questions because of lack of time, right? But you'll be able to solve advanced level questions as well of HC Verma or DC Pandey, right? And things will be very clear. Okay. Is that fair, everyone? Let me give you, yeah, I'm not showing the solution. Yeah, so let me give you one more question as homework. So this is a, another question as homework, and this is a question in which there is a wall. So you have to find out at what velocity should the projectile be, projected. The angle is fixed at 30 degrees. What should be the velocity so that it just crosses the wall? So figure out what are the, the values of x-axis, values along the x and y axes, and you will be able to solve this question. All right. Now let me start taking your questions here. Okay, so I'll give you this and let me start taking your questions at this point of time. Anyone who does not have any questions, right? The webinar is essentially over. Thank you very much. I just have one more poll, and that is this. Right? I only want to ask you this one small thing. Have you learned something new today? Right? Okay. And after that, I'll start taking your questions. Let's see. Soham, not really. These are not basic questions. These are questions which are taken from previous year examinations, right? Advanced level questions are, so the last question that I gave you, that is what an advanced level question looks like. And advanced level questions would involve multiple concepts as well. For example, someone had earlier asked that, take the question in which we project a bomb which explodes in the middle. So that would be an advanced level question. But remember, that question is also very straightforward. Why? Because even if it explodes in the middle, the center of mass will still follow projectile motion. So that is the way to solve that question. So we will come to that once we study the center of mass, right? Okay, moving on. Please guide how to start preparing for JEE. Yes. So the 4 questions that I was, I told you will be taking. Right. Let me answer those 4 questions now. Okay, let me just close the poll. So 81% said yes. I'm very glad. Thank you very much. 17% said no, but it was interesting. Again, in that case, also very glad. For all the 3% who thought it was a waste of time, I'm extremely sorry. Right? If you felt that it was a waste of time. Okay. All right. So let me start answering, your the 4 questions, the most important part, and after that I'll give you my contact details. All right. These are the links if you want. Yeah. First question was how to start. So the first part of how to start is basically figure out your target examination. Is your target examination main or is it advanced? See, if you start preparing for main right now, you cannot change it midway to advanced in between. That doesn't work, right? If you're preparing for advanced, right, you may not get a top 50 rank in mains, top 100 rank in mains, right? But you will clear mains definitely without an effort, and you will get a very good rank in advanced. So it's very, very important to figure out what is your target examination. Is it main? Is it advanced? Is it the state colleges? Is it BITS? Is it BITSAT? Whatever it is. So figure out what your target exam is, right? Figure out what the eligibility for that exam is. All those questions. Eligibility, what is the exam pattern, right? Exam patterns are different for different exams, right? So what is the exam pattern? All these things. Make sure you're clear of that. For example, for BITSAT, you need to score 80%. For all those who are in their drop year, if you are going for an improvement exam, you have to appear for all 5 subjects. These are things that you should know about. In JEE Main, you don't need to appear for all 5 subjects if you are below 75%. For JEE Main, 75% is the minimum requirement. So these are things that you should already know about before you start. This is point number 1, right? And point number 2 is, after all of these things, what is the syllabus? Break it down into parts, make a deadline for all of them, and then start preparing. I'll show you how to cover each of the parts. That is the 4th question. But this is how you basically prepare in 1 year or 2 year or maybe 6 months. What is the syllabus that you have? Depending on the given amount of time, can you complete the entire syllabus? If yes, break it down into smaller parts and make sure that make sure you attach a deadline for each of it. For example, this is where I'll answer the question for all those who are in 11th. If you're in 11th standard right now, okay, let's take one particular subject, right? In 11th standard, maths has a lot of algebra, has practically no calculus, and it has a lot of coordinate geometry. These are the two major sections that you have in 11th standard, right? In 12th standard, only the matrices part is there, and the probability part is there from algebra. The entire calculus is in 12th, and for coordinate only 3D and vector are in 12th. So essentially, algebra and coordinate are in 11th. So this is how I would target. I would want to finish off the entire algebra that I have by this is already June, so I would want to finish off the entire algebra by the end of September. And I would want to finish off the entire coordinate by the end of October. So this is the kind of deadline that you can prepare for yourself, right? This is something which can vary from time to time. Okay. Same thing you can do for chemistry. So in chemistry, you have a lot of physical chemistry. You have very small amount of organic and very small amount of inorganic. In 12th standard, you have a large, comparatively smaller amount of physical, but very large organic and slightly more inorganic compared to 11th. So these are things that you have to know, and then make sure that you give deadline for each of them. Make sure that you are able to adhere to that deadline. I'll talk about how to cover these topics as a part of the fourth question. Right. Next part is books. Right. What books to follow? So for any particular subject, the book number 1 is NCERT. For any subject, book number 1 is NCERT. Be it physics, chemistry, maths, do not skip NCERT. After that comes exemplar. Right. If your concepts are still not clear, you can take a break in between. However, for all the others, in the third case, you have books like for physics, you have H.C. Verma. Right. For chemistry, I would suggest any book which has a large number of questions, because for chemistry, this is sufficient. Right. But any book which has a large number of questions, for example, TMH, right, Singage, right, P. Bahadur, all these books which have a large number of questions, all these books are fine. Any one book is fine. Right. Pick one book and do it end to end. Very important. Right. For maths, again, after exemplar, go for R.D. Sharma. Right. All those who are targeting advanced, you have to go one step further. For physics, I would recommend D.C. Pandey. Do not solve Irodov. That is not required. Irodov is not required at all. Irodov is something which was studied by, even our seniors who had a subjective examination. Now there is no subjective examination. D.C. Pandey or Singage is more than sufficient. Right. Chemistry, this is fine, even for advanced level. And for maths, after R.D. Sharma, I would recommend TMH, but even Singage is fine. So any book which has advanced level questions, a large number of, see, all you're looking for after NCERT is a book with large number of questions, because that is the only drawback with NCERT. Okay, so that is what you get. And finally, at the end is previous year papers. So most of these books have previous year papers or, previous year questions, but that is an absolute part. Right. So this is question number 2. Okay. Moving on to question number 3. Question number 3 is, what should be your schedule? How much should you study? What are the number of hours that you should study? How many questions should you practice? I'm clubbing all of them over here. Right. So see, first of all, if I tell you that, if you study 8 hours every day for the next 2 years, you will clear JEE, that would be incorrect information. Right. If I tell you, if you solve 100 questions every day for the next 2 years, that would be incorrect information. What exactly are you studying in those 8 hours? That matters. What is the level of questions, or what are the questions that you're, what are those 100 questions that you're practicing every day? That matters. Right. If I only solve exemplar level questions or CBSE level questions, hundreds of them for the next 2 years, I will not be able to, clear JEE Advanced at all. Right. So that is why there is no answer to how many hours you should study and how many questions you should practice. That is going to be defined by you, and I will tell you how to define it for yourself. That is what I'm going to tell you. Right. So first of all, like I said, you have targets, right? Finish algebra by end of September, which means finish complex numbers in the next 15 days, and so on and so forth. So if you want to finish a particular chapter in the next 5 or 10 days, right, you would know how much to study so that it is finished in the next 5 to 10 days, right? If let's say, we are talking about AP and GP, right? Arithmetic and geometric, progression. This is a very comparatively easy topic, and it would probably require 5 days, not more than that, maximum 5 days, right? So if I want to finish this off in 5 days, I would probably want to finish off all the concepts around it in the first day itself. I would want to finish off NCRT and exemplar on the first day itself, right? Then I would move on to the next level, that is RD Sharma. RD Sharma will probably take me 2 days, right? So I'll go for RD Sharma. So this is how you set a target for yourself. For example, in the first day, the target that I have set is all concepts covered, NCRT questions done. So if it takes 4 hours, study for 4 hours. If it takes 20 hours, study for 20 hours. That is the key. The target is defined for you. You have to finish that target in that particular day. All right. Okay, so if NCRT has 30 questions in total, or maybe 50 questions in total, solve those 50 questions in that day. That is your limit for that particular day, right? That is how you solve the questions. Now, you have to make these very, tight targets, but they should also be realistic, right? Remember, there will always be spillovers. So maybe, out of 50 questions in the NCRT, you were able to do 40, and you have doubts in 10 of those questions. So next day you will make sure that those 10 doubts are resolved. You're able to do those 10 questions as well, right? And you're able to start with the next part. In a week, keep one day just for buffer, so that whatever is the spillover, that is covered in that week, right? So that is how you have to do. So this should essentially answer your questions regarding number of hours and number of questions, right? There is no fixed number for a particular chapter. There are chapters which would require you to solve hundreds of questions. There are chapters which would require to solve maybe not more than 30 to 40 questions. EM waves, why would you solve anything more than the previous year questions that have been asked, right? Alternating current, why would you solve more than 50 or 60 questions, right? Everyone, complex numbers, why would you solve more than 70 or 80 questions? But this number will vary. As long as you don't get full confidence in that topic, keep on solving questions. And that is the book that you're looking for, the book which has a large number of questions that you can practice. All right. So set a target for yourself and make sure you follow through. There will always be spillovers, but make sure that you ultimately cover it by, let's say 1 week or maybe 2 weeks. So there should be buffers in between, right? That is question number 3. The last question is where I tell you, what exactly should be the process of studying. How exactly should you study any particular topic? So this is what I would do. So once you join a particular course, I'm assuming also one more part over here. I was talking about books, right? So over here, if you have coaching material for any particular institute, let's say you join Vedantu, you'll get a lot of material from Vedantu. If you have joined some other institute, that coaching institute material is also sufficient. Do not go about buying more and more books, even though you already have a lot of material. Stick to one particular set and make sure you do it end to end. Very important part, right? Moving on, what should be the process? So this is the process that I follow. Before the class, make sure that you read the material. That is more like a teaser, right? You probably won't understand more than 10% of what is there in the class, but read it even then, right? Mark a few things maybe. Then you attend the class. Make sure that you ask as many questions as possible. Make sure that you don't make a lot of notes here. Notes come later. After that, come back and read again. This time you should be able to understand more than 80% of all the concepts. And this is when you make notes. Make concise notes for yourself. Make your own notes at this point of time. By now you have understood 80%. So you make notes of whatever you have understood and you add your doubts as well. So these are areas where you have doubts. Right. Next process is get your doubts resolved and start solving questions. So these are 2 things which will go on simultaneously. Right, you'll have some seniors, or maybe you're getting your doubts solved on WhatsApp, or maybe you have teachers. So get your doubts solved Yeah, everyone, welcome back. I hope all of you can hear me now. Yeah, so everyone, so this is how basically you solve each and every topic, right? This is how you basically study each and every topic. So these are notes which you will keep on updating with each revision, right? Every month there should be at least 2 or 3 days for revising whatever you've studied in that particular month. Every week, for all those who are in 12th and 12th, make sure that for every week you have at least 1 or 2 days for 11th standard revision, right? Every month attempt at least one mock test, right, on all the topics that you have already covered, right? And so on and so forth. The frequency should go on increasing. All those who are in 12th, your syllabus should be over by end of October or November, right? Everything should be over by that. In your case, you'll have to do a lot of common stuff. For example, let's say your syllabus goes on till December. You should even then start revision by October itself. So simultaneously, you are revising initial topics from October onwards, and you are finishing off the last few topics, let's say up to December. There's no problem in that. The final topics of any particular subject are actually very easy, right? In chemistry, the final chapters are probably environment and biomolecules and polymers and all these, right? In physics, you have semiconductors, which is actually not there in JEE Advanced, right? So all these topics are there. Modern physics, semiconductors, all these topics. So at the end, you always have easier topics, so you can always manage revision along with that. So that is the kind of management that you will have to do, right? So this is how you can, so if you follow this process, you will be able to cover everything up to advanced level in a very great detail, and you will be able to completely crack JEE Main. That is guaranteed from my side. Okay, let me share my contact details for all those who want to give me feedback regarding the webinar, or if you have questions. This is my mail ID. It means actually type it down. All right, everyone. So this is the mail ID that I have, and the phone number is okay. Is that fine, everyone? So this is the mail ID, avinash.kumar@vedantu.com, and the phone number is 9717938992. These are the two links on which we are available to take full-time classes, and the trials, they are ongoing. So join the trials. You'll get 6 sessions and doubt clearing for 1 week. After that, you can decide whether you want to continue or whether you want to get a refund. All right, everyone. Thank you very much. Take care of yourself. I hope I was able to answer a lot of your questions. If any of your questions are left, right, in that case, just email or WhatsApp me. Yes, let me give you the link as well. So basically search for this on Google, PHET Colorado, and over here go for projectile motion. Right, I can give you the exact link as well, but okay, let's see if I can do that. So I'm giving you the exact link in the answer itself. Okay, and it is in the chat. All right, so this is the link for the game that I was talking about. Practice this game, you will be able to completely understand projectile motion. All right, everyone, and when you go to these links, make sure that you click on avail now, the pink banner, and not the green one. All right, when the option is available to get this at 99 only, why would you want to go for 1000, right? Okay, so this is where we stop. Thank you very much. Take care of yourself, and right, let's continue this on these phone numbers and this email ID. Right, it was great fun. Thank you very much. Take care of yourself, and bye bye, everyone. By the way, all those who are looking for the recordings, you'll get an email for the recordings very soon, right? So don't worry about that. Okay, bye bye.